Alrighty. We're recording. Alright, good. Alrighty. Hello, my name is Matthew Donahue. My partner is Noel Z. Chavez. And here's our fluid mechanics project showing Poisel, Coet, and hybrid flow. So first thing we're going to do is we're going to open up ANSYS. We're going to make sure we have two fluent flow systems. We're going to go ahead and select them. And we're going to make sure that they're in 2D. That's what we want. So we're just going to do that real quick. First things first, we're going to go to our geometry. We'll make sure we open up Design Modeler. We don't want to open Discovery. And so we were given the specific instructions for this assignment to follow the simple formula of height times 150 is what equals our length. So first things first, we're going to draw our geometry out with a sketch here. Go down to sketching. We're going to pick a rectangle. We're going to draw our point from the origin. We're going to select the z-axis. That way we can kind of look at everything from this xy plane. Create our first bit here, which is our rectangle. Go to dimensions. Select vertical and horizontal because we're going to go ahead and change those dimensions to what we need. Make sure they're the correct length for what we calculate our Reynolds number and everything else for. So first things first, go ahead and change your units to millimeter. That way we're working in the correct units. So our horizontal, we're going to do 1500 because we're going to do a height of 10 millimeters. This way, following that condition we were given, which was the 150 times height for our length, then what we can go ahead and do is we can go ahead and select those dimension parts and delete them. The dimensions are already done, but this way we don't have those being in the way. So we're going to zoom in here. As you can see, we have our dimensions. Go ahead and we're going to pick pure pick box select. We're going to select our body here, our sketch. We're going to go ahead. What we need first is going to make a surface, and we're going to select our sketch here. We're going to apply it as our base object and generate our body here. All right, so now that we've done that, we're going to go ahead and we're going to exit. We're going to just close this part down here for now. And so now we have our geometry. Now we can go to the mesh. The meshing is going to be pretty straightforward. We're going to use the same meshing for all three fluid flows. It's just going to take some time because it's very complex geometry to generate. Depending on the computer you have or laptop, it may take more time than others. So first thing we're going to do is we're going to go ahead and start naming our edges, because once we go to the setup phase, we want to be able to see what we're actually working with. So this will be our upper wall. This will be our bottom wall here, or lower, whichever one you want to call it. You can call these whatever you want. This is just some easy way. This is our inlet. And then we have our outlet here on the edge. You're going to create the name section just so we're naming it. There we go. We have our name sections. You can see here, you'll have all of them there. So we're going to go ahead, we're going to select mesh, insert, sizing. First thing you're going to do is you're going to click that one. Make sure you do control click. So you select both. Click the geometry to apply those two edges. We're going to change the type to number divisions, and we're going to do 2,500 divisions. Just so we can make sure that the meshing is pretty fine and everything works out pretty well. Capture curvature, we do not want to capture it. We're not really interested in that part. And then we want to make sure it's a hard behavior. So once we have all those settings complete, you press generate, and you'll probably have to wait like 3 or 4 minutes for it to generate. You're going to repeat this process again once they finish generating for our inlet outlet, but it will take some time. Alrighty, so there's our first mesh. We're going to go back to mesh. We're going to insert another sizing mesh. Like mentioned, it's going to be between our inlet and our outlet. Make sure you apply that geometry, switch it to number of divisions, but since we're going to change this one, for this one we're going to do 100 divisions. Not going to capture the curvature again, and this one's going to be a hard behavior. Once you have all that done, you can press generate, and then we have to wait yet again. Just give it a little bit longer. Should almost be done meshing. There we go. So there we go. We got our size meshings done. So we can go ahead here. You can kind of see it's already starting to show the mesh. We're going to go ahead and pick a face mesh. We're going to select this, apply the geometry, and generate it. This one will take less time compared to the other ones. It's a more simple meshing, like it's already done. There we go. We finished our meshing. And the best way you can see to make sure everything is working, everything is done correctly, is you can just zoom in. And as you can see, you can kind of see the fine shape of it. I mean, you can kind of see the individual boxes. The more you zoom in, the more you can see. But when you zoom out, it will just have that solid color here. So once we're done with that, we can go ahead, we can tab out of here for now. You're going to go to your meshing, you're going to update it. This way it updates that to the geometry. And now we can go to the setup phase. This is where you're going to make your conditions for the flow. So biggest thing here is we get the meshing and geometry done. That's more or less just building our pipe. Now the setup is where we actually can start putting the conditions in to create that Poiseuille flow. So this first one's going to be our Poiseuille flow based off of the dimensions and everything. Now in this part, you do need to actually take in consideration what you want your numbers to be. The recommended thing to do is make your density just 1, and then your viscosity and velocity. You can just calculate those along with what you want for the Reynolds number to be. Now for this one, the first thing we want to do is we want to go to models and go to viscous and make sure that we're on laminar flow, a laminar model. This way we're actually in the correct conditions. So after that, we're going to go to material, go to fluid. We're using air. So here's where you can change that density. We're going to make that 1, and here's our viscosity. For our Reynolds number, we chose a Reynolds number of 945, so that way we're under that 2500 range, and we're not in a transition range either. We're more towards a laminar flow. So our viscosity is going to be 1 e to the negative 5 kilograms per meter seconds. And then we're going to go ahead and change that so that it updates here. We want that to be 1. Boom. Once we press change and create, you can go ahead and close this part. Tap up here, that we can close that. Next thing you want to do is go to your results just real quick. You want to change your residuals. Is basically just what you're like going, the numbers you're going down to. We're going to put it down to 1e negative 6 just so that way we can have the best amount of data we can. Just going to copy and paste that. Never mind. Just copy and paste that into each box to save some time here. So once you have that done, you can press OK. Residual is more like where your data is going to, is like the range of it kind of idea. Next thing we know, cell conditions, fluid, just make sure it is on air and it's at the correct. So we have it as air, that's what we want. Go ahead and close this. Boundary conditions is the next part we're going to check. So our inlet, we have a velocity inlet here. This is where we're going to input our velocity value. So as you can see, we can change our velocity. We're not going to change down here. That's going to stay 0. Velocity we calculated with to get our Reynolds number is 0.0063 meters per second. You're going to press apply to make sure it saves that value in there. Now we're done with our inlet. Outlet is going to be a pressure outlet. This is also where that naming the edge part comes in handy because then you can see where everything is. So we want to make sure we press that prevent reverse flow. We don't want that in this scenario. After you apply, you can close, and that's all you have to do with the outlet. We go to our walls here. We want to double check both walls to make sure they are stationary with no slip condition. We can see the upper wall is done correctly. The lower wall is also meeting those conditions. So we can just close out of there. We don't have to work with that. So we can close the boundary section. Next, we got to go to our reference value tab. This is where we're going to kind of reference all the values for everything when we do the initialization. So we're going to go from our inlet. And notice how everything goes to the dimensions and values we put in. Well, it's not going to go the exact thing, but you want to make sure it's from the inlet to surface body. This will make sure that we're actually we're going to go from here to over here. So once we're done with that, we can go down to initialization. It'll take a second to load. I'll close that just to hopefully. There we go. So now after we have that, we have hybrid initialization, initialize it. Just gotta wait for this to finish processing before you can run your calculations. Okay, there we go. That's done. Next, we're gonna go to our run calculations tab. So you're gonna want to run over 100 iterations at the very least. In this project, we chose to run 200 iterations just to be in a good range. Usually it's 200 to 300 is the range to do it. And then you're gonna go ahead and press your calculate. Now you're gonna have to give it some time to calculate all those values. When your screen freezes up like this, just give it a moment, and there you go. Now that we got that little screen that tells us all of our calculations are done, we can close out of here. Boom. Our solution's already going to be updated with all the data we just put from the setup, so we can go straight into our results section. And here's where we're going to put the contours, the vectors, and our velocity profile. So first thing we're going to do is pull up this 2D view. We're going to want to put in a location, go up here, pick lines. So we need our midline, where that's going to be our middle point. So in this case, it's going to be 0.750 because we have a 1500 long thing. 750. Make sure you make it the height of your pipe. So in our case, since it was 10 millimeters, it needs to be that. We're going to do 100 samples. And once you press apply down here, you should see that yellow line appear. You can go ahead and put another line here. This one's going to be called our end line. This is where we're going to put it towards the very end. So that's going to be at that 1.4999. So it's like right there at the edge. So we get the best data we can. And then we're going to go ahead and put it at that height with 100 samples, apply, and you can see it's right there. Now, just for like an example, we're going to add in an extra line here that's going to be like this, towards the beginning or towards the left. So we're just going to call it left. And that one's going to be sitting at like 0.10 millimeters from the starting point. Go ahead and fix that. This way we can kind of see the flow before it fully develops with 100 samples. We will only be doing it for this first one just to kind of show as an example. As you can see, it's right there. Next thing we're going to do is we're going to add our contour. We're going to go ahead. Location is going to be symmetry. So you can pick that whole body. Switch it to velocity U, which is what we want to measure. And we're going to do 110 number of contours. Once you press apply, let it load for a little bit, and then we'll give you that contour profile. We get this, as you can see, we get our contour. We're just going to quickly move this out of the way. So we're going to make it horizontal and fixed up top. Apply so it's up here. You can see the velocity kind of ranges from what we gave. It's a little bit, it's not entirely up to that 0.06063, but you can kind of see it goes a little bit above it. So if we zoom in, you can kind of like, if we zoom in, you can kind of see how we go from like being at a very low relative to zero velocity. As we get closer to center, we get to that higher velocity and then back to that lower velocity with that whole bit because we have those no slip condition and stationary boundaries. Now we're going to add our vectors. So we're going to come up here, press this button, add a vector. We're going to select our location to be that symmetry 1 again. We're equally spaced. For this instance, you can choose how you do it. This is what I prefer. We do 100 points. We're going to go over here to symbol. We're going to choose 3D arrow just so that way you can actually see it. Once you press apply, now you can see those velocity vectors throughout the whole contour rather than just see, because if you don't do that, you'll just see small little lines and you will only be able to see them at the edges. This way you can actually see them through the whole pipe if you like. Next thing we're going to do is we're going to pick our chart. You don't really have to name any of this stuff. Just make sure the chart title is our velocity profile. And then this will be for our Poiseuille. Well, and then we're going to go XY line. Data series 1 is going to be our left point. So we're just going to do that just so we can have a reference, like just give you an idea of like it developing flow. Then this will be our midline. And then we'll add the third one, which will be our end line. Once we've done all 3 of those, we can go to our x-axis. We're going to change the variable to velocity u. The y-axis, we're just going to make it a y value rather than anything else. When we click apply, we should see a velocity profile generate. So as you can see, everything's kind of at the same, like you can see a small change in there. Mainly if I go through here and I was to delete, like, let's say the end line part, you can still see your midline and then you press apply. You can see that end line, they're all overlapping because by the point we can see that flow is already developed. So in this case, we're just going to add back that end line part. But by the midpoint, we see that the velocity the flow is fully developed, so the velocity is going to follow the same profile. And there we go. And we can see that this is the general shape Poiseuille flow will have with its velocity profile. As we get away from the boundaries, we increase our velocity to our max, and then as we head back towards them, we go back down to 0. So we can click out of here. Just let it click out, because now that we've done all that, that is for our Poiseuille flow. Can I just go close this? Okay, so next thing we're going to do is this flow system is going to be for both our coet and hybrid because we're going to use the same geometry and meshing. I will just be changing the setup, solution, and results sections. So we're going to go into our geometry, which you remember to click it to go to model, not to discovery, like this. Discovery takes a long time to load and is not really what you need to use to make a sketch for the pipe system. Now it's opening discovery, so we're just going to close that because that's not what we're going to use here. We're going to go back to geometry. Once it finishes, the system finishes loading. Design modeler, which is the one we want to use just like we did in the first instance. We're going to click on our Z-plane, go to sketching, make a rectangle, and we're going to go from our origin again, just for simplicity. Go to dimensions, vertical, just like before. In this case, we are going to downscale our pipe a little bit for the co-ed flow. Just it makes it a little bit easier. Make sure to switch your units to millimeter. So we're going to go with a height of 5 millimeters and a length. 150 times the height is 750 milliliters. And those are our dimensions. It's going to be very small. So we're going to go ahead and click out, and then we're going to click there so we can just go ahead and delete these two parts because they're just going to get in the way. Next thing you can do is going to go to concepts, surface from sketches, go up here, box select, select your bit, apply the base objects, and generate, and it'll give you a surface from your. So you can see it's gray. That means you got your surface. So now we're going to go ahead and click out of this. The geometry is already done. We're going to click on our mesh, and this is where we're going to repeat that meshing process. We're going to do the same thing for the edges, the mesh dimensions, all that stuff. But because we have new geometry, we got to go through and do it again. So just got to wait for it to finish loading. We're going to go back to that Z axis. Okay, as you can see, go here. We're going to zoom out a little bit so we can see everything. Go here, we're going to select it. After we select the edge up here, we're going to go ahead down, create new section again. This is going to be our upper wall. You can call it whatever you want. This is just for later once you're messing with the setup, you have something to actually go off with the name sections. And then we're going to label our inlet. And then we'll go over here to our outlet. All right, we have our name sections. So then we're going to go here, our mesh, insert another sizing mesh. We're just going to repeat the process like we did last time. Select our things, apply the geometry, go by number divisions, 2500. And then we go here, put the capture rate to no, behavior to hard, and then we press generate again. There we go. Now we're going to go back to mesh. We're going to insert our second sizing mesh from the inlet to our outlet. Apply number of divisions, 2500. Or no, this one's going to be 100. Go here, go to no, and then change that from soft to hard, and we'll press generate again. And we will now wait for this meshing to complete, and then we can go ahead and do the face mesh, which should take a while. There we go. It has loaded. So next what we're going to do, go up here. We're going to select our face mesh, select our entire thing, apply that geometry. All these conditions are all right. We don't want to change those to suppressed. Everything here is what we need. Unless you have any other need to, you can change them. But for this instance, we do not. We can go up here and press generate. And there we go. That one was nice and quick. So once we're done with our meshing. Then you just got to go ahead and update your meshing like we did before. Just let that update. So that way everything is completed. Just give it a minute to update that properly. And then we can go into our setup phase. Now we are going to be changing how we set up the thing because we are the flow because we are going into a coet, not a Poiseuille flow. So it will be slightly different this time. We're going to choose the double precision. And so for co-et flow, we do have a moving boundary and a stationary boundary in this conditions. So once this finishes loading, we will go through the process again this time, but we're going to change a few things that way we can mimic that co-et flow system. Alrighty, we're all good to go. Go to models, gonna make sure it's on laminar. Once that's done, we can get out of models, go to materials, go to our fluid and air. So based off the Reynolds number we calculated for our co-et system was 1500. So for this one, we used a density of 1 again. And then our viscosity is 0.001 or 1 e to the 3. You can write it either way. And then you're going to press change create. Boom. Can get out of here. Go to cell conditions just to double check that it is using air. You should always make sure because in case that isn't there, you're going to get very different results. Go to our results page. We're going to go change our residuals again to that 1e to the -6. We will see a little bit of an issue. It will give us an error message later. I'm not exactly sure why it gives us that message. I believe it's because we just don't hit down to this value, but at the end of the day, we still get the same results if we do or not. Next, we're going to go to our inlet. We're going to change it from a velocity inlet. So what you're going to do is you're going to click on it, and you're going to go to type, and you're going to go down to pressure inlet because we don't want a velocity coming in. You're going to leave all these like they are, but you're going to prevent reverse flow and apply. Then you can click out. Go to our outlet. Our outlet's already pressure, so we just got to press that prevent reverse flow and apply. That's good. Now we go to our walls. Our lower wall we need to make sure is stationary with no slip condition, just like we did in the first bit. So that's all good. Now we go to our upper wall. Our upper wall is going to be the one that's going to have a velocity to it. So we're going to switch it from stationary to moving. It's going to keep that no slip condition. Our speed we calculated with was 2 meters per second. And we're going to press apply. This is going to give us what we want for that moving boundary condition. So we can close all that. We're going to our reference values again. We're going to select it, go from our inlet, and you can notice all the values get corrected to surface body. And now we can go down and we can initialize the hybrid again. We're going to let that run. This is where we're going to get an error message just because we don't reach down that level of accuracy down there. That's okay. Next, we're going to go, it's going to take a minute to load just because of that. All that means is it doesn't reach down to that 1e to the -6. We're still getting value data that will work for what we want. It's just not reaching down to the same precision we want. That's okay. It's not going to cause any issues. If you really wanted to, you could try and have everything run down there. We're going to go to run calculations. We're going to choose 200 again, and we're going to press calculate. And then we're going to let that load to process all those calculations. All right, now our calculations are complete. We can close out of this. Just because unless your computer can handle running everything at once, I don't recommend it. I doubt many laptops will be able to run everything with all your tabs open. So it's highly recommended you keep them closed, just that way you can process everything at a decent speed and not crash the whole application. Just gotta wait. Go ahead, click on here. Give it a second to update everything. There we go. So now we can go to our results section. All right, so we have our pipe. We're gonna go ahead and create our lines again. This time we're just gonna do a midline and end line because we don't The left line beforehand was just more of an example line to kind of show a difference in flow. And then we're going to put that exactly at halfway point, make it the same height as our pipe. And then we're doing 100 samples. Press apply, and our line is there. Go ahead and make our end line. We're going to make this one at the very edge. So it's going to be that 74999. Same thing here. And then 0.5 with 100 samples and press apply. Once we've done that, we're going to go ahead and we're going to add our contour. Select symmetry 1 so we get the whole thing. Velocity U, global. You don't have to do anything, and we're going to do 110. Press apply and let the contour load. Then we're going to move the graph here out of our way. Same way we did beforehand. We're going to switch it to horizontal, fixed, and apply so it's up here so you can see. Real quick, we're going to zoom in just so we can see it with our co-wet flow here. We can see we have our low relative zero velocity down at the bottom towards the lower plate. And as we increase and go upwards, we get a higher velocity all the way up to that close to 2 range with that relative no slip condition. Next thing we're going to do real quick is we're going to add our vectors. So we're going to choose symmetry 1 again, equally spaced, 100 points, go to symbol, and do our 3D. This way you can see them actually in it, the contour, and not just be small distortions in it. I'm going to press apply again. And there we go. You can see all of our contours. They're going to be, obviously, vector is going to have that magnitude. So as you kind of go upwards, you can see the color change along with the size difference. So there's our vectors. There's the vector contour. Next thing we're going to work on is our chart here. So we're going to go up here, we're going to press that, create a chart. And this is going to be our velocity profile. Next thing, make sure it's XY line data. We're going to go ahead and make this our midline. And then add another point. This is going to be our end line. But at the end line location, x-axis is going to be our velocity u again, and y is going to be at that y value. Apply, and there we go. We get our velocity profile for wet flow, which is going to be a linear profile, because as we increase the height from the bottom plate to the top plate, our velocity will reach up to its maximum up there, and will steadily increase in a linear way. So now that we've done that, we've gotten our co-wet and Poiseuille flows. So now we'll move on to the hybrid flow. So we're going to close out there. So what we're going to do is, since the hybrid flow, we use the exact same meshing and geometry as the co-wet, we're just going to go to our setup selection again, double precision again, and we're just going to switch around some of the setup conditions. That way we can mimic that hybrid flow. So imagine we just kind of skipped out, we already made our geometry, did the meshing again, just to save some time for this demonstration, so we don't have to add on an additional 10 minutes to this video. Just waiting for everything to load up. All right, so we got everything back. So if we just made every fresh one, make sure we're a viscous laminar. Materials, we're gonna go to fluid, and we're gonna keep that density at 1. And for our hybrid flow, our conditions were we had density of 1, our viscosity was 1 e to the negative 4. So we're going to go ahead and change that real quick. So there we go. We're going to close out, close our fluids. Cell conditions, we can check. We're going to just check to make sure it's an air fluid again. It is, so we're all good. Boundary conditions, we're going to go to our inlet. And we're going to change that back to a velocity inlet. And then we are going to have 2 separate velocities, one for the inlet and one for the plate. So the inlet velocity we went with was 0.8 meters per second. We're going to go ahead and apply that. And then your outlet's going to be the same thing, pressure outlet. You just want to make sure it has the prevent reverse flow. And then we're going to go to our here, go to our upper wall, which should be the moving wall. We're going to change that velocity from 2 to 0.4. Our total velocity between the two plates should be 1.2. With those values and our viscosity of 1 e to negative 4 and then the density of 1, we should get a Reynolds number around 100. That's the round number we calculated for with the dimensions of the 750 millimeters and the 5 millimeter height. So we're going to apply that. Once that's done, all that's good. We go back to our reference values, double check that our inlet and surface body are all in the correct way and they have the right numbers, which we have everything. And then we're going to go to our results, double check our residuals are 1 e to the negative 6. They're all good, so we can get out of there. We're going to go ahead and initialize this. Once that's done, we'll run our calculations with 200 iterations again. So it's done. We're going to go here, run calculations of 200 iterations, and let that load now. All right, our calculations are now complete. Press OK, and we can close out now. So now everything's been updated. We can go back into our results page. And we're going to go ahead and just remove the stuff we worked on real quick for the co-wet flow. Now, if you wanted to do the hyperflow from scratch, you would just, like we did before, go through the geometry, make it the dimensions you want. You can keep it the same dimensions. We're just going to go ahead and get rid of our charts and everything. So then we're just stuck with the profile and our lines again. So we do the same thing. And we'll go ahead and just redo everything from scratch here. Make our line, make a midline. We're going to put that at that 0.375. Same thing down here, 0.375. And put that 0.005 with 100 samples. We apply that, we get our midline again, location and line. And then we're going to put this at that very end so we can get data from midpoint and at the very end of our pipe. Make sure to put the height in there and make it 100 iterations or 100 samples. Fine, we get our little line all the way to the very end. And then we can go ahead here and we're going to go ahead and add our contour. Symmetry 1, velocity U, global with 110. Apply. All right, now we got. So next thing we're gonna do is we're gonna add our vectors into this. Add a vector. Location is gonna be the same we chose, symmetry, equal spacing, 100 points, symbol. We're gonna choose the 3D arrow so that way you can actually see it and then apply it. And then you can see it. So if you zoom in, you can see all the different velocity vectors here. You can see it like how they change the colors and size depending on the magnitude of the velocity. So now we got our contour with our velocity vectors. We're going to add our chart in now to get that velocity profile. So we're going to change the chart title to velocity profile hybrid flow. And it's going to be an XY line data series. We're going to repeat the process again where we're going to go midline. And it's going to be at that. And then we're going to add another one. It's going to be called our end line. We had our end line location. We have our 2 data points. Change our x value to velocity u again, and our y back down to that y value. Press apply, and there we go.